Welcome to the last lesson in this unit, which is finding the shortest distance from a point to a line. If you are given any point defined as P with coordinates x and y, and you are asked to find the shortest distance between this point P and an existing line with an existing equation, the shortest distance is by drawing a perpendicular line from P to the given line. Perpendicular means they form a 90-degree angle, and calculating what the length of this line segment is. Now, how do we solve for that? It's pretty hard, because if we want the shortest distance, what does shortest distance mean in real life? Shortest distance between two cities. I want to find out how many kilometers are between two cities. Shortest distance between the kitchen and the bedroom, shortest distance between the house and a neighbor's house. Whenever we hear shortest distance, what we have to think of is the length of that line. That is the first thing that should come to mind when we talk about shortest distance. Now, since we're looking for the shortest distance between a point P and a given line, it means we need the length of the line D, the line segment D, right here. Now, for this line segment D, we only know one point. And in the length of the line formula, if we write it, we know that we have to have a minimum of 2 points, because we have x2 minus x1 squared plus y2 minus y1 squared. So, since we only have 1 point, we need another point, but not just any point. Since I need the shortest distance from a point to this line, I need the end point of the line segment D. I need this point right here. So we have two lines intersecting at one point, which is the red one over here. Now let's think about it. When did we deal with point of intersection of two different lines? Well, I'm pretty sure you remember in Unit 2 when we solved linear system, what we were actually solving for was the point of intersection between two lines. Let's call this point Q, with coordinates x1 and y1. If we know point Q and we consider P the second point, so it could be x2 and y2, then we can solve for the length of line segment D, or we actually now can call it PQ. Now we're getting a little bit closer, however, it's still not that easy. Okay, how do we find the point of intersection when the only thing we know is the equation of this particular line? We know the equation, for example, in this first example, is 3x plus 4y minus 2 equals 0. How do we get from knowing one point and one line to finding now the point of intersection and calculating length of a line? Well, let's think about what we know about line segment D and the given line. We know that D is perpendicular on the line. What does it mean for two lines to be perpendicular? Well, we hopefully remember that when two lines are perpendicular, they have negative reciprocal slopes. So, first thing first is I want you to rearrange the given line in y equals mx plus b form. So, rearrange the given line in y equals mx plus b. Why is that? Because the slope of the given line will give us a clue as to what the slope of line D or line segment PQ is. So the slope of PQ will be the negative reciprocal of M over here, because the two lines are perpendicular on one another. Now that we know the slope of PQ and we know point P with coordinates x and y, we can actually construct the equation of PQ. So I want you to construct the equation of PQ or line D. Why do we need to construct the equation of PQ? Well, we said that if we would have the equation of line PQ and the equation of the given line, we can form a system of equations and solve for the point of intersection. So, in 3, you are gonna use line PQ and the given line to solve for the point of intersection, which in our case we labeled as Q with coordinates x1 and y1. And last but not least, once you have Q, since we know P and Q, you're gonna calculate the length of PQ, which is the shortest distance from point P to the given line. What I want you to do at home is follow these instructions step by step, and even if you make mistakes, I still want you to go through with it and try your best to calculate the length of the line. So on the website you have the worksheet for this particular video. Please follow each particular instruction, either from the video or from your worksheet, and calculate the shortest distance from a point to a line. And in class we'll hopefully have an easier time to go through some more examples and clarify any questions that might come up in solving at home. Good luck!